All right, so last time we looked at section 7.2 part 1, and I just went over some of the things that you need to know from that section to do this section, and some of that stuff we're even going to use later in the week. So keep in mind that ASTC diagram, okay, telling you where the trig functions are positive, the formulas in those quadrants for working with reference angles. And I think for today, those are the two big things you'll need to know. Okay, so the goal is, what we're going to try to do is we're going to take something that looks like this, okay, or like that, and we're going to get rid of all the trig in it. Okay, we're going to convert that into something that's just algebra. Okay, so if it's just an algebraic expression, that means there's no sines, there's no cosines, nothing like that. Okay, so somehow we're going to turn this all into algebra. Okay. Before I go through the steps, does anybody have an idea of how you would do that? Take something that has trig in it and get rid of all the trig? No? All right, so let's take a look at it. So what you want to do is you've got two functions. You've got an outside one and an inside one. We're going to start with the inside one. And what we're going to try to do is take that inside function and we're going to turn it into a picture, okay? Something we can visualize. Okay, so as far as the outside function, you can really you can forget about it for now. Okay, so we're going to turn that inside function into a picture. Specifically, we're going to turn it into a right triangle diagram. And when we want to draw something as a right triangle, generally we don't deal with inverse trig functions. And that's what's on the inside, though. So the other thing we're going to do with that inside function is we're going to turn it from inverse trig into regular trig. And then from there, we're going to have to remember the definitions of our trig functions. Sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, and so on. Okay, so we're going to start with that inner function. And if the inner function contains inverse trig, we're going to rewrite it using regular trig. If the inside function already is regular trig, then we're going to solve that a little differently. Okay, we'll look at those later. So the two kinds of problems we're going to look at is where inverse is on the inside and regular is on the outside. And then we're going to switch it. Okay, but we're going to start with the ones where inverse is on the inside. Okay, and as we're solving these problems, keep in mind formulas you're allowed to use with a right triangle, Pythagorean theorem. Okay, and there are also restrictions on the angles. Since we're going to be drawing a right triangle, we're not going to get negative angles. So if something comes up negative, we want to be careful. That's not right. And because we're working in a right triangle, we can't have an angle bigger than 90. If you had an angle bigger than 90, they wouldn't add up to 180. Okay, so there are some restrictions on the angles here. But if you draw everything correctly, these kind of restrictions should just automatically happen. It's not really something extra you need to worry about. Good. Okay, does everybody have the steps? All right, so the one we're going to do, the inside trig function is inverse, and we're going to start with that, and somehow we're going to turn it into regular trig. So for now, you can forget about sine. Okay, we're just going to focus on inverse cosine. Now, anytime you use inverse cosine, okay, so like I do something like this, 0.5 inverse cosine, I get 60. What is that? 60, what does that 60 represent? If I was solving a problem, it would represent something. Yeah. It's an angle. Okay? Anytime you press inverse a trig function, then hit enter, the answer that you get represents an angle. Right? Do I know what this angle is in this problem? No. When I do inverse cosine of some number, okay, between -1 and 1, okay, it has to be between -1 and 1, I'm going to get an angle. I don't know what the angle is, but I'm just going to represent it as theta. Okay, just a generic way to represent an angle. So everything that I just circled, I'm pretending that that's theta. Any questions on that? So really, what I'm going to be looking for once I draw a picture is the sine of theta. Right? Theta is all this stuff I circled, inverse cosine v. Right? So now we need to make a picture of inverse cosine v equals theta. Now I said we're going to take that inverse function and turn it into what? A regular trig function. Okay? So we're going to rewrite it. So how can I get rid of inverse cosine? This is a function. Okay? How can you cancel out inverse cosine? And we had formulas we looked at last time. We had 6 of them. And I showed you when inverse cosine would cancel out. You have to do something to it. Well, what if you had this? Okay, you've got a function there. Okay, you're squaring. How would you cancel out that function? Yeah? Yeah, you take the square root. So what's the relationship between squaring and square rooting? Yeah? They're inverse functions, right? Square function, square root function, they are inverse. And if you take a function and its inverse and combine them, they cancel each other out. Square root, square, and there's your answer. So now my question here is, what would I have to do here, kind of the same idea, to cancel out inverse cosine? What function could I combine it with that would cancel it out, just like I did on the right? Yeah, take the cosine of all of that stuff. But if I do it on the left, I got to do it on the right to keep everything balanced. Okay, so you're not multiplying by cosine. Sometimes I hear people say that. Cosine is a function. Just like here, I didn't multiply by square root. I took the square root. I took the cosine of both sides. So I haven't really done anything other than now I have this. V equals cosine theta. The statement I have now is exactly the same as the statement I started with, except now it's written with regular trig instead of inverse trig. All right, now I want to draw a picture of this. And I've got some information here that's going to help me draw it. Okay? In this picture, I need to put theta somewhere. Does it matter where I put theta? What do you think, Amanda? Well, putting theta in different spots is basically just like taking this picture and turning it. So it doesn't really matter where you put theta, because if you put it at the bottom, somebody could just take the piece of paper and flip it, and now theta's at the top. They're just looking at it a different way. So I'm going to put theta here. But if you want to turn that triangle around and pretend like it's on the bottom, you could do that too. It doesn't matter. But what's the one fact that I know about theta right now? I only know one thing about it.
It's less than 90.
Okay, so I take that back. Maybe I know a couple things. It does have to be less than 90. I'm thinking of something a little more abstract, something not numeric. There is something I know about theta.
It's equal to B.
Theta equals V?
Cosine theta equals B.
Yeah. Cosine of theta equals V. So when we're talking about cosine, what does cosine mean? Yeah? So cosine, you don't have to write this if you don't remember it, you probably should. Cosine is adjacent divided by hypotenuse. So I know what the cosine is supposed to come out to. Somehow it has to come out to V. So pick something for the adjacent, pick something for the hypotenuse, but you have to pick two things so that when you divide them, you get V, because that's what it has to come out to. So what could I pick for the adjacent side, and what could I pick for the hypotenuse, so that when I divide them, the cosine comes out to V? Yeah?
You just do V over 1.
Yeah, you could make the adjacent side V, and make the hypotenuse 1. Now, if you take the cosine of theta, it's adjacent over hypotenuse. It's V divided by 1, and that's what you're supposed to get. Okay. Now, the answer we're looking for is what goes in that circle. I have the cosine of theta. But what is the problem really asking for? It's asking for the sine of theta. But as long as I know one trig function of theta, I can figure out other trig functions. What two sides does sine involve? It's opposite over hypotenuse. Do I have any of those sides right now? Yeah, which one? I have the hypotenuse. Do I have the opposite? No. I don't have this. I'm going to put that there temporarily, but I'm going to know what that is shortly. How can I figure out what this side is in terms of the other two sides that I know? Yeah? Yeah, do the Pythagorean theorem, okay, set it up, and then you'll be able to figure out what this side is in terms of the other two. Okay, just use the Pythagorean theorem. So Amanda, can you tell me how to set up the Pythagorean theorem using the letters I have right there? Yeah, v squared plus x squared equals 1 squared, which is just 1. And now my goal is to get x by itself. Okay, so what would be the first thing I do to get x by itself? Subtract v squared. All right, so I've got x squared equals 1 minus v squared. No, not square both sides. Square root. Okay, we want to cancel out the square. So take the square root of what's on the left. Take the square root of what's on the right. Remember, you cannot simplify when you have addition or subtraction under a root. So you can't cancel out the v in the square. Okay, so that's the length of the bottom side. It's the square root of 1 minus v squared. Okay, so I don't need to call it x anymore. Now I know the adjacent side, I know the opposite side, and I know the hypotenuse. I can find any trig function you want me to, including the one that they asked about, which is sine. Okay, so sine is opposite over hypotenuse. All right, so Zach, what side is opposite theta?
Square root of 1 minus v squared.
Square root of 1 minus v squared. And then I would divide by the what side would I have to divide by? Yeah, I'd have to divide by the hypotenuse, which is,
1.
in this case, it's just 1, so I don't have to put it. So that's the answer. It's the square root of 1 minus v squared. All right, so let's try that. Somebody give me a number for v, but it has to be between -1 and 1.
0.5.
Yeah, point 0.5?
Yeah.
All right. So let's plug in 0.5, and I'm going to take the inverse cosine. and then I'll take the sine. Okay, so we have the sine of inverse cosine of 0.5. I'm just going to switch over to radians. And we get 0.866. In fact, I think if I did that in degrees, I think I'd get the same thing. Let me take a look. Yeah, it doesn't matter because you're canceling out the trig function. So yeah, you get 0.866 either way. Now let's plug 0.5 into this formula and see what we get. Square root of 1 minus 0.5, and you have to square it. 0.866. So what we did is we just took a formula that had trig in it and converted it to a formula that doesn't have trig. Any questions on that? Okay. And if you look at v, okay, I said v had to be between -1 and 1 because that's the domain of inverse cosine. If you go back at the section I just reviewed with you, you'll see that. But why does v have to be between -1 and 1 in this function too?
Because you used it in the original one.
Well, because I used it in the original, but let's just say I gave you this on paper. This was it, just the thing I circled, and said, what's the domain of v, or of this function? And pretend you're an Algebra 1 student. That's all you know, just up to Algebra 1.
Can't be negative.
Why? What can't be negative?
The n square root.
Why not?
Then it's imaginary.
Yeah, then it would be imaginary. So v has to be between -1 and 1. Pretend v is 2. You'd have 1 minus 2 squared is 4. 1 minus 4 is -3. You can't take the square root of a negative number. Okay? So if you didn't understand why v had to be between -1 and 1 in the trig function, hopefully you do in the algebraic function. Okay, it can't be imaginary. Okay, so any question on that? And when you're done, it's always a good idea to check it, like I did, with a specific number and see if the formula works. All right, let's try another one of those. Once you've done one or two of them, they're all the same. You do all the same steps pretty much every time. And once you get good at them, you might even be able to skip some of the steps, like drawing this diagram if you don't need it. All right, so now following the same steps we did last time, can anybody tell me what my first step would be here? Okay, take the middle. You want me to write it down?
Yeah.
Okay.
And then equal theta.
Yeah, set it equal to some angle. Okay, so we're basically letting all of this be theta. Okay, you're taking the tangent of some angle. And now what do I want to do with that equation? Take the sine of both sides. So that's going to get v by itself. And what's that mean? V equals sine theta. Okay, so now we've just rewritten this as regular trig instead of inverse. Okay, now what? Okay, we're going to draw a picture. All right, so I drew my right triangle. What do I have to put in that triangle? Theta. Where? Yeah, sure. Put it at the top. And now, can somebody explain to me how I need to label these sides? Explain to me what my goal is. What am I trying to set up right now based on that fact? Yep.
Would it be so you can do the Pythagorean theorem?
All right, eventually we want to be able to do the Pythagorean theorem, so we have to label two of the sides. Which two sides am I going to label here? Opposite and hypotenuse. And you can pick anything you want for opposite and hypotenuse as long as what happens? They don't have to equal v. The opposite side has to, you mean like opposite and hypotenuse both have to equal v?
No, like in the equation, like opposite over hypotenuse has to equal.
Yes, when you take the opposite and divide by the hypotenuse, you have to get v as your answer. And there's lots of ways to do that. So can somebody tell me one way I could do that, preferably the simplest way?
Opposite is B.
Yep,
I thought it was 1.
is 1. Now, we basically just had this kind of set up in the other problem. Does anybody remember what the adjacent side is going to come out to if you do Pythagorean theorem? Yeah. You can go through the Pythagorean theorem again if you want. X squared plus v squared equals 1 squared, but it's the same thing. Okay, if you're ever not sure of that, go through the theorem because it doesn't always come out like that. It depends on the sides that you know.
So, are you giving it the exact same answer? Of the weight 8?
No, because the outside function is, we're looking at something different this time. So now they want to know the tangent of theta. Well, here's theta in your picture. So what's the tangent? What's the formula for tangent? Yep.
Would be the square root of 1 minus b squared over b.
So yeah, tangent would be opposite, which is v, over adjacent. What you said was cotangent. We could do cotangent up, we're just not in this problem. Okay, so there's your formula. V divided by the square root of 1 minus v squared. The only problem with that is if this was like a multiple choice question, you wouldn't see the answer written like that. Why not? Yeah, you're not going to leave a square root in the bottom. So how do you fix that? You multiply the top and the bottom by the root. So it's going to be v times the square root of 1 minus v squared divided by 1 minus v squared. What's under the root and what's in the denominator are always the same when you do this. So this is how you'd probably see the answer written. V times the square root of 1 minus v squared over 1 minus v squared. And if you want to check it, pick a number for v between -1 and 1. Plug it into the original, plug it into the new one, and see if you get the same answer. But you will. So I'm not going to do that this time. Okay, any questions on that? All right, so I'm giving you problems that you can do. All right, you can't just take any trig function and convert it to algebra. Some are a lot harder than others, like this kind of problem. If I said to you to convert that to algebra, that's actually a lot harder to do. Even though there's not as much stuff in this problem as the ones I'm asking you about, it's kind of hard to find an algebraic formula for sine. Okay? But there are ways to do it. I mean, there is obviously some kind of program in the calculator because you can press 30, you can press sine, and somehow it gives you an answer. So there's a method for how do you figure out the sine of 30? Like, what do you actually do without a calculator? Okay? But we don't have to. We're not going to worry about that. Okay? In calculus, you might talk about how you could do that. Okay. Right. Does anybody need to see another one of that type? This is the same type. Inverse on the inside, regular on the outside. You do the same thing again. Okay, what's different about this one? Yeah, the inverse is on the outside. So this one we're going to solve a little differently. Okay, the way we're going to solve this one, we're still going to start with what's on the inside. We're going to try to figure that out first. And then we'll worry about what's on the outside. All right, so let's start with trying to figure out the tangent of 3 pi over 4. What is 3 pi over 4? What is that in degrees? Well, Francisco, do you know what 3 pi over 4 is in degrees? Well, do you remember how to change radians to degrees? How we convert it? Close, you're kind of on track. We don't add though. No, we don't add or subtract when we're converting between radians and degrees. Yep, Alex. Multiplied by what? Yes, multiplied by 180 over pi. So if I do this out, 3 pi over 4 radians is going to give me how much in degrees? Up top. And it's probably easier to reduce it first before you multiply. Yeah. All right, so that would be the tangent of 135. So now 135 is a multiple of what number? Special angle. Yeah, Josh? It's a multiple of 45. So anytime you want to find a trig function of an angle that's a multiple of 45, or we could also do multiples of 30. Okay, we're not in this problem. How do you do that? There was a whole couple sections on finding trig functions of angles that are multiples of 30 and 45. Remember how we do that? Without a calculator. Well, Andrew? Remember? Want to help them out? How do you do trig of an angle that's a multiple of 45 or 30? You can't do what I'm thinking of if it's not. Like I would never ask you to do like the sine of 37 in your head. Okay, it's got to be a multiple of 45 and 30. Well, what is asking like what the angle is a multiple of? What do angles relate to that we do a lot in trig? Angles relate to something. To what? Okay, so we're getting on the right track. Can you explain more about coordinates? Right, can anybody build off that idea? Something with coordinates? It has something to do with a circle, yes. The unit circle, all right, we're getting really warm here. So we have to somehow draw a unit circle and something with coordinates. All right, so let me draw a unit circle. And what would I do now? I'm just labeling my unit circle. Do what?
Isn't it square root of 2 and
I don't know yet. I don't have a point on there to find coordinates of. Right now I just have a blank, just a circle. So what should I do? How am I going to show what I'm looking for on that circle? So Amanda's figured out like a lot of it. So how about somebody else tell me something from here? Well, what's the angle that I'm working with? 135. Okay. So I have this circle, and I've labeled it. So what should I do with the 135 degrees? Yeah, put it on the circle. Okay. So where is 135 degrees? In between 90 and 180. It's exactly halfway between. Okay. So I'm going to label that. And now, what do I really want to know about that point? Is something I want to figure out now. Yeah? Well, the radius is a 1. I can tell you that because it's on the unit circle. So that side's a 1. But there's something else I want to know about that point. What do I want to know about that point? Yeah? I want its coordinates. Because if I can figure out its coordinates, and then we can remember the formula for tangent, I can figure out what the tangent of 135 is. Right? And that'll tell me what's going to go inside those parentheses. Okay? So it'll figure out that whole part of the problem. So I'm going to draw this into a shape. I'm going to turn it into a right triangle. And now I have to remember something else. I've drawn a special right triangle. If you know what this angle is a multiple of, you know which special right triangle I just drew. And knowing that, you should know how long the sides are. Yeah?
45, 45, 90, 2 squared to 2 squared to 1.
So that is 1. And then can somebody, can you say those sides again? The legs?
Negative. X, negative.
Okay, I wasn't even thinking, but yes, one of those will be a negative. But something about the number you said. What did you say for the length of each side? So what do you think the length of each side is?
Square root of 2 over 2.
Yes, it's the square root of 2 over 2. I think you said 2 square roots of 2 the first time. Square root of 2 over 2. And one of them is negative. Just keep that in mind too. So now let's write the coordinate. The x value is negative square root 2 over 2. And the y value is square root 2 over 2. Okay, so we know the coordinate. Now, what's the formula for tangent using x's and y's? Or if you remember Sokotoa, it's the same. It's really the same thing. This is your reference angle right here. What is it? The negative one, right. The formula, let's put it down here. Formula for tangent is y divided by x. It's really just opposite divided by adjacent. So when you take the opposite and divide by the adjacent, just remember that adjacent goes left, so that's negative. When you divide those two things, you get negative 1. So now we've just figured out what the tangent of 3 pi over 4 is. Okay, if you have your 45, 45, 90, and 30, 60, 90 memorized, you don't even have to draw this diagram. Okay, you can pretty much just do it in your head. So like if somebody asked me, what's tangent of 225, I'd just say 1. It's these two numbers, and it's a negative, negative. If somebody said, what's the tangent of 315? I'd say negative 1. Because it's these two numbers again. One's positive, one's negative. And then if someone said, what's the tangent of 45? I'd say 1. It's these two numbers, and they're both positive. You can also tie that in with the ASTC and figure out what's positive where. Okay, we got a negative 1, and we definitely should get a negative when we're dealing with tangent in quadrant 2. And we did. All right, so any questions on how we got negative 1? Okay, so you have to use inverse, use unit circle trig, or just memorize your 30, 60, 90, 45, 45, 90 triangles again. All right, so now I need to figure out the inverse sine of negative 1. When I solve this problem and I get a number, it's going to be inside that circle. What is that number going to represent? It's being calculated from inverse trig. It's an angle. So the answer to this problem is an angle. So let's write down what we know right now. We know that the inverse sine of negative 1 is an angle. It's some angle. Now, what could I do with this to make it a little easier to work with so I don't have to think about inverse sine? And we did this earlier. Yeah?
Multiply by something? Oh, well,
Take, yes. Take the inverse sine of each side. And you get this. -1 equals sine theta. And you might be like, well, whoa, wait a minute. How can that equal a negative? Remember the quadrant limit. Okay. Sine equals -1. All right. So now let's draw a picture of that. Okay, let's just draw what sine looks like. It looks like this. And it keeps going. It goes forever, remember, in each direction. What's the highest and the lowest that the sine function goes? Yeah, the highest it goes is 1, and the lowest is -1. So we just have to figure out where does sine hit -1. Now it's going to hit it infinitely many times. They didn't tell us which answer to write. So I guess technically we could write any answer we want. What would be the first positive answer where it hits -1? What angle is that at? Remember, this is the third tick mark, but it's not 1, 2, 3. It doesn't go by ones. It goes by pi over 2s if you're doing it in radians, yeah? Or it goes by 90s if you're doing it in degrees. You could do it either way. Let's do it in degrees. It's 270. You could write that as an answer to this problem. Or it also hits -1 back over here. What quadrant, or what would be that answer? -90. Now, even if you didn't have the picture, how could you take this answer and turn it into that answer if they wanted? You can always add or subtract 360 and get an answer somewhere else for sine. Okay? So either one of those answers is acceptable. Okay? 270 or -90. I'm just going to scroll back up and see if the directions said write your answer as a positive. Nope, I don't see that anywhere, so we could write either answer. 270 or -90, or there's an infinite number of other answers, which I'm not going to write. Does anybody know what answer the calculator would give me? Because the calculator is only going to give me one of these. Well, I still have the other page up from the notes. Let's go back and look at inverse sine, and let's look at the range, okay? The kind of answers that you get from inverse sine. Okay, let's go back. Look at the range of inverse sine. This is in radians, but what two numbers is inverse sine always between? -90 to 90. So even though 270 is correct, the calculator is not going to give you that one. The calculator would give you -90. Okay. Right, so there's a lot of different things in that problem. Okay, setting up a unit circle and then knowing your special right triangles, and then from there figuring out the inverse sine of -1. Okay, I thought of it as a picture because I know where sine hits -1. I wouldn't have you do one by hand and I'd ask you where sine hits, say, 0.36. You can't do that by hand. Okay, it's got to come out to a nice number, like a 1 or a -1, if you're going to do it without a calculator. Okay, and how would I know you do it without a calculator? I would see that you had to draw this diagram to figure it out. I can see that. But you can always double check your answer after by typing this in, and the calculator will give you -90. Hey, any questions on that one? That's the only one I'm going to do of this type. It's a little different because the inverse is on the outside. Regular was on the inside.
Did you just say that the only way you know that we did it without a calculator is if we had the unit circle?
Yeah, or some kind of work you'd have to show me, yeah. Or if you didn't draw the unit circle, you could explain and say, well, I know from the unit circle the coordinate is this, and if you take y and divide by x, you get -1. So you could write that instead of drawing the unit circle. Yeah. Right. Any other questions on that? All right, let's try. All right, let's try this one. These two are kind of the same. Now, this one kind of goes back to what we did earlier. Inverse is on the inside, regular is on the outside. It's just like example 1a and 1b. Inverse on the inside, regular on the outside. But what's different between this example, and the first two that I did? We have an actual number, right? So we know the opposite and adjacent sides. Well, I'm saying that because we're dealing with tangent, or we will be. But the opposite and adjacent sides are going to be actual numbers this time. So we're not going to have to deal with a v and a 1. All right. So we can go through and draw the whole diagram and set up those equations. But does anyone think they can tell me, just jumping right to the diagram, what two sides am I going to be labeling? Opposite and adjacent. And how long is the opposite? 1, and the adjacent? 2. You don't even have to set up that equation, inverse tangent theta equals, or inverse tangent of a half equals theta, and then take the tangent of both sides. You can, but it's just going to give you this picture, exactly like we did example 1a and 1b. Now, what would the hypotenuse be? It would be the square root of 5. And now I want the cosine. Remember, I let my picture represent all of that. So I'm finding the cosine of the angle in my picture. So what's the cosine of theta? 2 square roots of 5 over 5. Perfect. And this is the kind of problem on the graphing calculator, you won't get that as an answer. If you type this in, you're going to get a decimal. Okay, the only way to get this exact answer, just like I did here, is to do what we just did. Any questions on that one? All right, let's, since I think we're almost at the end, let's do that one real quick. Somebody tell me what I'm labeling here. Opposite, and how long is that? Hypotenuse? 2. So now to find this side, it's going to be 4 minus 1, and then take the square root of it. So it's the square root of 3. You can double check my answer. Just square this, you get 3. Square that, you get 1. Add them up, you get 4. Take the square root. There's your hypotenuse. Okay, so what's the cosine? Actually, you know what? I'll just put it up here. What's the cosine of the inverse sine of a half? Yeah. Square root of 3 over 2. Okay. Any questions on that? It's just like we did at the beginning, except now you're using actual numbers instead of letters. I think that's actually a little easier. All right, so when we're solving a trig equation like this, a couple things you have to keep in mind, and I think I already reviewed them in the first part of the section, is that trig equations are periodic. What does that mean? There's infinitely many solutions. Now, sometimes the directions might say, only find the solution between 0 and 360. Or find all solutions between 0 and 360. But sometimes the problem might just say find all solutions in general, like this one. Find every single solution there is to this problem. So since there's infinitely many solutions, you obviously can't write them all down. We've talked before about how you can represent all solutions in general. So we'll get to that in a second when we solve this problem. See if we remember how to do that. If they're asking you to solve a problem like this one, you don't have an inverse cotangent button. So you're not going to be able to cancel out cotangent with inverse cotangent. It's a good idea, but you just don't have a button for it. So we're going to have to think about how we would type that in. Yeah, but we'll do that one after. Does everybody have what they need for that? All right. So let's start with this one. Right away, I want to ask myself, how many answers am I looking for? I'm looking for where the sine function equals a positive number. How many places does that happen on the coordinate plane? 2. Somebody tell me, where are the 2 spots that sine would come out as a positive? The first and the second. So I'm looking for answers, if you're thinking degrees, I'm looking for one between 0 and 90, and another one between 90 and 180. If you're thinking radians, I'm looking for an answer between 0 and pi over 2, which is about 1.57. And what's 180 in radians? Pi. Or if you're thinking as a decimal, it's about 3.14. Let's do it in radians. So how can I get one answer and get x by itself and get rid of sine? Yeah, take the inverse of everything on the left, take the inverse of everything on the right. Inverse and regular cancel out, and right away we have one of our answers. Inverse sine of 0.6. Okay, so I'm going to switch over to radians. I'm going to type inverse sine. This is not one you could really do in your head easily. And you get 0.64. Okay, what quadrant is that in? That's my first quadrant answer. Okay, so I've got the answer there. All right, next. I need my second quadrant answer. So how do I get the second one?
Did you just add it to 1.57? We don't subtract it.
Yeah, we want to subtract it from pi. Okay, you want to subtract it from 3.14. And if you're not sure if you did it right, you can check your answer after very easily. So let's take 3.14 and subtract 0.64. Okay, 2.5. Now, just to check it, let's take the sine of 2.5. And when I press sine, what should I get about on the calculator? I should get about 0.6 if I do it in radians. So 2.5 sine, and I get 0.59. Okay, it should be 0.6, but that's because we rounded. And we can check 0.64, and we get the same thing. Now, the problem said to find all solutions. I haven't done that. I've found 2 specific ones. So how do I represent these solutions in general? Think about how often they're going to repeat. That's a good starting point.
Would you represent them as x?
Okay, you're going to need a variable in here somewhere. Yep. But first, let me ask, how often is this answer going to repeat, this 0.64? Every what? Every 2 pi, which is the what of this function. 2 pi is the what? It's the period. Okay, these answers are going to repeat every period. So how would you represent, let's just say, adding 1 period to that number? What would you add to 0.64 if you wanted to add 1 period to it? 6.28, which as an exact answer is 2 pi. Now, if you wanted to add 2 periods, you could put 2 pi times 2. If you wanted to add 5 periods, you could put 2 pi times 5. What if you wanted to add n periods? 2 pi n. And you might be like, well, wait, didn't you say you could also get answers then a negative? Yeah, pretend n was a negative number, like -1. That would be subtracting 2 pi. Okay, so this n has to be what kind of number? Because you have to add multiples of 2 pi. 2, 4, 6, 8. So what does n have to be? We can be a little bit more general than a whole number. It can be an integer. Okay, it could be -3, and that would be -6 pi, so that would subtract 3 periods. All right, so as long as n is an integer, you can add or subtract any multiple of 2 pi. Right? And we have to do the same thing here. So these are the answers in general. Okay, any questions on that? All right, so let's try this one. Pretty much the same steps, except there's one thing that complicates a little bit. You can't just start by taking the inverse of this function on each side, because you don't have that function. So cotangent is related to what other regular trig function? Tangent. So if I know the cotangent equals something, then I also know what the tangent equals. What's the relationship between cotangent and tangent? They're reciprocals. So if the cotangent is 2.5, what's the tangent? It's 1 over 2.5. Now I have a problem I can solve just like the last one. Okay? I've converted it to a trig function that I have a button for on the calculator. So Kayla, what would I do on each side here?
The inverse tangent.
Yep, take the inverse tangent. All right, so let's see what we get. Remember, we're looking for where tangent is equal to a positive number. That happens in 2 spots. Second, inverse tangent. I've got 0.38. And what quadrant is 0.38 in? That's a first quadrant answer. Okay, we'll come back to what we need to add on the end of that in a second. And what other quadrant is tangent equal to a positive? Yep, third quadrant. And how do you get an answer in quadrant 3 using your reference angle? Yep, pi plus the reference angle. And we get 3.52. Now same thing that came up last time. These are not all the answers. Those are 2 specific ones. So you always put plus the period times n. What's the period of the tangent function? What is it? Nope, it's not pi over 2. Anybody remember that? Period of tangent. It's pi. Yep, period is pi. So I'm going to put plus pi n plus pi n. And now those are my 2 sort of answers. I'm going to show you something here. If you wrote that, that would be okay. But let's go up to our other 2 answers. All right, let's take let's clear the screen. Let's take 0.64 and let's add multiples of 2 pi to it. So that's the first answer you get. Okay. Plus, and I'm going to add another 2 pi. Okay, so now I'm doing 2 pi times 2. That's the next answer. And the next one, and the next one, and good enough. Okay, so I'm just going to take those answers, make them a little smaller, and those are the answers that you get from that one. Okay? Now let's take 2.5. Let's do the same thing. Take 2.5 and add 2 pi, and I get that answer. Did I get that answer before? 8.78? Nope, so that's a different answer. Let's add 2 pi again, and again, and again, and again. So look at the answers that I got here. Are they repeats? Or are they different? They're different. So the answers that I got from those two equations are unique answers. Everyone agrees with that? These are all unique. Okay, let's do the same thing down below. Let's take 0.38 and let's add pi. Okay, I get 3.52. And let's add pi again. And we'll do it a couple times. And look at the answers that I get. Does anybody already notice anything that's going to happen? Yeah, look at, it's hard to see, it went off the screen, but 3.52 was the first answer that I got from this top equation. That's also the answer in the bottom equation. So if you take 3.52 and then add pi to it, look what I get. I get that same answer that I had in the top equation. So what does that mean about these two equations? What does that mean? Nobody? Besides Mr. Beck. Well, what does that mean? Look at the answers. What are they? What are the compare the answers you get in the top, compare the answers you get in the bottom equation. Yeah.
They're equivalent?
Yeah, they're the same. These two things are the same thing. You don't need to write both of them. Okay? You could write just the top one, and that covers everything. That's a little bit different than the example we did with sine because of the period. Okay, it just has to do with the period. So here I would definitely expect to see both. Here, if you wrote both, I wouldn't take off any points, but I'd be really impressed if you said that these were repeats of each other. Good. Any questions on that? All right. One other thing. What units did we use on this problem? Radians. What would you put to represent all answers if I asked for it in degrees? On, say, this answer right here. What is it? What is this? Pi. So what is that in degrees? How much? 180. Yeah. You put 180n. And what would you put on this one? You put 360n. Yeah. To represent all answers. Yeah, but you only have to put the plus 2 pi n or plus pi n, whatever you're putting, if they say to find all solutions. Okay. All right. So I think that's a good place to stop. Okay, so homework tonight is 394. And I don't know, it looks a little short. Should I add some problems, Mr. Babb?
No.
Yes.
I should add. You guys want me to add some? No? Okay.
Like, but
All right, we'll stick with those problems then. 37, 38, 41, 42, and then 44 to 53.